How will you build email send time optimization for Amazon consumers worldwide? Hi everyone. Today we have Bilwa. He's applied data scientist at Amazon. Today we will do a data science mock interview with business case type question. The question for today is, how will you build email send time optimization for Amazon consumers worldwide?
Yeah, thanks, Viraj, for the intro. And so we can proceed with the question. So before proceeding, a bit about myself. I'm Bilwa, and I work as an applied scientist at Amazon. My day-to-day work involves building machine learning models from scratch and trying to cater to Amazon's huge customer ecosystem. So I work in the Amazon Kindle team, and as a part of my work, I also build like novel models in computer vision, NLP, and all. And I also take some time in mentoring folks at Amazon and also contributing to Amazon research fraternity. So Viraj, like if I have to rephrase the question correctly, so you're interested to know that what exactly is the end-to-end algorithm that I'm going to build to make sure that, say, Amazon is going to send some emails to its subscriber or potential subscriber uh, for a potential email marketing campaign. So in that case, how can you perform a send time optimization? And this will ensure that we have better customer satisfaction and we are getting more traction in the final, in the final outreach of the product that we are going to sell to the customer. Yeah.
Yes,
Okay.
that sounds good.
Okay, so I have few clarify question in the beginning. So what exactly is the motivation for this particular thing? And can you just give me an idea of the volume of customers whom we are trying to address? And what's the location? Is the location limited to say us any particular continent, or it can be say all around the world? Yeah.
Okay. So in terms of the location, let's start with US as the primary location, but we want to eventually expand that worldwide. So you help us understand how will we achieve that. And then the second piece is what we're trying to do is from a business point of view. So many businesses, they reach out to their customers through email. Through email, we tell customers about, hey, these are the different products that we have, or hey, these are the things that you were viewing or you have put in your cart but haven't purchased. So we kind of send them some reminder emails. And the purpose is to help them either discover new items or help them complete their shopping purchases, or also send them information about the deals, because deals expire. So we want to be timely in our communication. So these are the objectives from business point of view. And we think we need to understand when our customers prefer to receive emails. So different people may have different preferences. So we would like to send them email which is close to their kind of preferred time, maybe. That would help us drive our metrics and also help with the customer satisfaction.
Got it. Yeah. So okay. So then we can narrow down the problem to say the Amazon retail like ecosystem, right? Because we are mostly going to deal with like people who has purchased some products or who are the potential customer if they will find some value out of it. Okay.
Yeah.
So yeah. So now moving on to the requirements gathering section. So what we can do is that we can take a sample size of data. Like maybe we already have some historical data that tells us about emails that were sent to the customer and how exactly they behaved with respect to that particular email. So yeah, so I'm assuming that we already have that particular data. Like we have the cadence of the data that how the customers responded to that email, like whether they just simply opened it or after opening are they kind of clicking that particular button and they are kind of moving to the desired web page where they're supposed to be. So what you can do instead, so let's before moving on to the technical side of it, let's try to take a sample size of data and let's try to see that what's the percentage of percentage of responses which went through a click through rate kind of thing, right? So there are two aspects of it. One is that a customer is opening an particular email but it's not doing anything, so it's a passive action that he or she is taking. And the second option is that they're opening the mail and they're actually clicking that particular URL and they are redirected to the page. So what we can do is that say we take last 1 year of data, like historical data, because I think 1 year has the total like volume of data for capturing any kind of seasonality and any kind of trend in the data. So with that particular data, and say we take around 500 customers, right, as a part of the sample size, and obviously we need to do sample with replacement in order to have it in a more randomized fashion, so that we kind of neglect any kind of selection bias or any kind of statistical or survivorship bias. So this will help us in making sure that we have a good sample of data that's kind of reflecting the population.
For sampling, do you have any recommendation of what type of technique you want to use?
Yeah. So we can do like we can simply take stratified random sampling, and or we can also go for reservoir sampling. But I think stratified random sampling is easy to do, so we can do that. Yeah, with replacement. So what we can do is that say initially we are kind of limiting ourselves to 1 year time frame, but later when we are going to scale it up, we are definitely going to capture some say 3 years of data. Yeah, that is for the next part, next iteration. Okay.
Okay. And would you walk us through what type of data granularity would you need?
Okay, yeah, sure. Yeah, I'm just
Okay.
moving towards that. Yeah. So what you can do is that we are going to create, like we will be having some different sources of data. One is that we have an historical data, right? So that is something that is already existing. We are simply going to get the user response for each email that Amazon is sending. So I hope that there is some kind of bot, or there is some kind of like a service to capture that particular record. So that's for the historical data. Second is that we can actually create some new data, right? Like as a part of our experimentation, we can actually kind of keep a time window of say 1 month, and within that 1 month, we're going to send some new set of emails to the customers, right? And we'll be kind of tracking their behavior. That's the second option. I mean, that's the second step. And the third step is a data augmentation kind of thing, where we can simply have some synthetic data that's going to capture that how the customers actually have responded to some data. So that can be curated with respect to, like, it will be inspired from the historical data that we have. So now we will be having three sources of data, right? So moving on to the historical data. So what we'll be having is that we are now moving on to the technical aspect of it. So we have some feature and we need to build a model out of it. So before jumping into an ML solve, like, let's think that whether any kind of heuristics based tool can actually serve this particular purpose, because we did not make anything complex, but we can simply use a very simple solution. So what you can do is that if you think from a heuristics point of view, that say that we are kind of targeting all the US places, and customers are there in a different region, like say US East, US West, there is the central part of US, anywhere. So now once we have that particular data, and we already know that this is the customer response, right? And say if we kind of have some kind of rule, and if we check how is the customer likely to behave, right, for this particular data, and we see that okay, the heuristics model is not scaling well, right, and say the accuracy, the performance that we have, that is not kind of scaling well. So in that particular scenario, we are going to move on to some intelligence solution, like say any kind of machine learning. Okay.
What kind of criteria you would have to decide between, hey, let's go with the heuristic versus let's go with the machine learning, or is it like a step up approach? How do you approach it?
Okay, yeah, right. So for that, we can have a step in between. So what we can do is that we can curate some set of metrics, right? That we need to perform, like that we need to measure our model. So there can be two aspects of it. Like from an applied scientist point of view, we can have a set of science metrics, right? But the set of metrics that we actually require, that these are the business KPIs, right? Like say if we actually take some like way out, so how exactly it will improve the click-through rate. Like say there is a like a mail, and the customer is opening that, and say there are 100 such mail, and out of 100, how many they're actually clicking that particular rate, and they're landing to the website. So this particular click-through rate will give us the impression that the customer is actually interested in this particular product, and and this particular email is kind of satisfying this particular problem statement. So click-through rate is one particular like performance metric that we can think of. And apart from that, we can actually think about some other KPIs, like say there is something called customer satisfaction, right? Where we can actually request the customer to kind of review this particular like experience, and say how many out of how many reviews we're getting some positive response, right? So from that we can get a score of the customer satisfaction. Similarly,
Okay.
we have some, yeah, we have some other metrics like say customer effort score. We can have like metrics like say customer lifetime value, retention rate. What exactly, like if suppose that 1 month before we have n number of customer, and say later we have m number of customer, then what's the ratio of n is to m, right? So from that we can get a metric of the retention rate. We can also kind of track any churn, right, in this particular period, so that our main motive is to reduce the churn rate. So this will also help us gauge the performance of our metric, like of our model and all. And we can also maybe for a final like judgment, we can also use something like a customer lifetime value and all. So
Okay.
overall these set of metrics are going to kind of give the impression that the customer, like everything is fine, or something needs to be kind of optimized, right? So now with this being said, what we can do is that we can compare the heuristics based model, and say we talk with some like the stakeholders internal to Amazon, who are going to kind of take it forward for the production thing. So now if they tell us that okay, this, say we are getting a performance metric that 70% or 75% whatever, and this is not something that is kind of reaching the bar. So we need to raise the bar here, and this is not something that is below the, like this below the benchmark. So we know that okay, heuristics is not able to solve the problem. Why not we move on to a machine learning based approach, right? Now
So,
we now
can you give a couple of examples on the rules, example of rules that you would use in the heuristic model?
Sure. Yeah. So what you can do is that, like, say, we already know from the historical data that, say, some hundred number of people have opened this particular email, in their respective email IDs, and out of these hundred, say 45 of them are actually visiting that particular page, right? The desired page. So we know that okay, the click through rate is 45% here, right? And say for all these hundred, there is some like Amazon follow-up mail, like where the customers are actually seeking, like they're supposed to review this particular thing. And say from these hundred, we're getting a customer satisfaction score, like CSAT score of say 35, right? So now we know that this is something like a 35%. But say that the business knows that it has the potential to reach a click-through rate of say 70% from 45%, right? Or say a customer satisfaction value of say 65%, whatever, right, from 35%. So this is the room for improvement that is there. So we cannot limit ourselves to a heuristics based approach. So we know we have already seen from the data that these kind of rules that we're applying, this is not going to scale well. So we need to go for some intelligent model. Yeah.
Okay.
Yeah. So now we move on to the machine learning part. So first comes the data collection part. So I have told that we can collect some data from the historical data, and we can also conduct a test run, like not a test run, like conduct a survey for 1 month of data. We can have some good amount of data out of it, and we can also do some data augmentation. So from these three data, we are going to collect our data. Now,
Okay.
once we do that, yeah, we go forward with the data cleaning part, data pre-processing, and all these things. Like if there is any null value, we remove that. We do a couple of data imputation and all, and after that we move on to the feature engineering part, right? So now in the feature engineering part, what we do is that we are going to define the like the functions in our ML model, like what is the input feature, what is the output level, and all. So for the sake of generality, I am assuming that it's a supervised learning as of now. So we know what is the input level or the input feature, and we also know the output level. So for the input feature, we have the time of the day, like when the email is reaching the customer, and we also have some binary predictor value, like if he's opening the mail yes or no, 1 or 0 kind of format binary value. If like he's actually moving to that particular page, given that he's opening the page.
The
So we
clicking.
have, yeah, correct, yeah, the click-through rating. So we have this set of say n number of feature, right? And the output is that finally if he's landing towards that particular page, yeah, for all these criteria. There can be some other input feature we can think about, like say if the customer is a existing buyer at Amazon, or he's a newcomer, like I mean he's a new buyer, right? So that particular information can come from his product purchase history and all. So that also we can have, right? And also what's the total number of orders that a customer has given, because if one has multiple order, then he or she is very likely to visit the page often for in terms of deals and all, right? We can also have a new input column for deals and all, like what's the likelihood of him to visit the deals page, right? So in this way we have a couple of input feature that we have. Next, we move on to the machine learning part of it. What you can do is that we need to feed
So,
our model.
the question on
Yeah,
that part. So,
sure.
we also
Yeah.
wanted to optimize when the email is being sent out so that it fits into customers' prefer window. Do you think there are any additional uh, factors you will consider to achieve this?
Sure. Yeah. Yeah. I'm moving towards
Okay.
that thing, right? Yeah. Yeah. So, yeah. So this is the ML model that we are going to build for predicting if any customer is likely to click that particular link or not. So that's one ML model. But the thing is that we actually need some additional ML models that will be using the data, using this particular data to so it will be consuming that particular data from model one, and it will move on to the model two. So now I'm going to talk about the model two thing.
Okay.
So model two will do, it will be a regression kind of thing where we know that what are the values for the input feature, and the output will be, this time the output is not going to be a binary classification thing, rather it will be a regression kind of thing, like where we can tell that okay, at this particular time the customer is likely to open like his or her email, and they're likely to click that particular date. So now this particular data will come from all the existing mails that Amazon has sent. So this is something from the customer's own data point of view. So the first model that I talked about, that is from Amazon's point of view, that Amazon has a collection user database of all the customer. And then the second model, right, that is for each individual customer. So this is where we are going to import the best practice for personalization thing. So that means our model is going to cater to each and every customer, and not
Okay.
only to like a set of customer and all. So it's going to make sure that all the customers are benefited out of it. Because I can give you an example. Say customer one is kind of opening his mail in the evening, right? And maybe say customer two is opening her mail in the morning time frame. So now this kind of data we need to generalize, right? So we have to build like a different set of model, right? I mean different set of model from each user's point of view, each user's data that they have. So so that means what we have is that there is a principal model M1, right? And for each M1, right, I mean for from M1, given the user data for say 500 data that we talk about, for 500 user, we are going to build 500 incremental learning model. So these 500 models are going to tell us when the customer is likely to open his email and also click this particular like his mail. And Amazon needs to send this particular mail for each customer at that particular point of time. So this is a regression model that we are going to build for each customer. And so the main benefit out of is that we are going to personalize this particular thing. It's simply like a recommendation engine that we are building, but here instead of a user thing, we are focusing on user item collaboration thing, right?
Okay.
So
And
yeah.
then, can you help us understand how will you test the model? How will you
Sure.
launch?
Yeah. Right. Yeah. I'm going to that. So yeah. So now what we have that, like say I'm taking the best practice of ML. So say I'm taking gradient boosting. I mean extreme gradient boosting, XGBoost, right? For building the principal model from Amazon standpoint. And with that particular result that we have, we are going to kind of float some 500 different model. Now these 500 is 500 today, but it can be say 1,000 tomorrow. It can be 10,000 the day after tomorrow, right? So we are going to scale it up. And Amazon has like different service like SageMaker, MLPGen and all, where we can actually deploy model of this particular data set. The thing is that the data set won't be that huge. So for that reason, I'm restricting myself to machine learning only. I could have thought about deep learning, but the thing is that for any customer, right, we cannot have a huge set of data. So the data set is going to be limited, right? So then deep learning is going to overfit, and it will be like overkill for this particular statement. So we are limiting ourselves to machine learning. And in the second part, we can simply use a say a random forest regression. So it will be computing multiple decision tree which are randomized, and it's going to compute the final prediction that what's the time window. So we'll be having a 24-hour format that at which particular time, given the probability, this customer is likely to open his mail. So
And
basically how the yeah yeah
to your
please
point,
please go
how
ahead.
do you make decision between going with this Amazon SageMaker versus building kind of your own model?
Yeah, sure. So the thing is that how we so in our machine learning life cycle that we follow. So what we do is that we in the POC phase we try to build a model in our local system, right? And from there we are going to kind of scale it up for like we'll be writing the code in SageMaker point of view, so that there is an API endpoint that will be exposed to the SageMaker, and every time we do a batch run, for each input data, it will be triggering the SageMaker response, and like a SageMaker request, and then a response will be generated. It will be predicting the model for at inference, right? And then once we have that particular data, we are going to send it to some operations team who are going to do the audit for us. Now from the audit, we know that okay, if this particular data is, I mean, if this particular prediction is actually suiting our use case or not. So what we can do is that we can now come to the A/B testing part of it. So now we have the result for these 500 people. Now we can do one thing. For these 500, we are going to conduct the A/B testing. That means we send them the mail at some random time, or maybe say some fixed time, say 12 p.m. At their local time, and then we compare it with the B version of it. That means the predicted time that we have computed from the machine learning model at inference. So now from that particular data A/B testing, if we see some kind of a like optimization, then we know that okay, this is successful. Now suppose it might happen that the A/B testing is not giving some correct result for many of the customer. Then what we need to do is that we need to retrain our model. Like we need to take a step back, and then we need to retrain our model with some different model. We can see model optimization that we can do, and then it will be an incremental approach, like iterative and incremental approach. And then finally, we can again come to a final version of A/B testing, and then the model is going to be ready for production. Yeah.
Okay. And then how do you approach this problem of taking the model for US, which is working,
Yeah.
and scaling it worldwide? I mean, what kind of
Sure.
2-3 steps you will follow?
Right. Yeah. So now, say our model is performing well for these 500 data points, right? Like these 500 customer that we have, and say we are also computing the new click-through rate and the new customer satisfaction value, all the scores that I've talked about initially for all the KPIs, and say we are in talks with the business management and other stakeholders in our team and external teams who are going to approve if the model can go to production or not. So now we are coming to the final phase of scaling this particular model. Okay. So what we can do is that we can actually take help of the distributed machine learning approach that we have. Like say, this is for 500 data points that we talked about. But now what we need to do is that, like, we have the principal model that we talked about, like that will be classifying the user, right? He is likely to do a click through or not. And from that particular data, they are going to like spawn a new model for each customer that we have. So what you can do is that we can simply use some GPU, like I think we can also do it in CPU, right? But if suppose the necessity arises, we can do it in GPU platform, and we can do the scaling out of there. So what you can do is that we can have some new metrics, like what's the scalability before and after, if there is any latency that's there, like additional latency, or we are seeing some better time complexity. The third one is that we can talk about the capacity, what's the storage size for this particular model, like the end-to-end model that's hosted in SageMaker. And fourth one is that what's the maintenance and the like if this particular model can be deployed for other use case, similar use case, right? What's the potential scope for like interpretation of the model, and is it portable? Like if we can leverage our model for a different use case, so we can think from this point of view, and finally we can shoot for the launch thing, right?
Got it. And going back to the other part, where how will you take it to the other countries? I mean, do you need to do any changes to the model,
Right.
or do you need
Okay.
to
Yeah.
retrain it?
Correct. Yeah. So obviously we need to retrain it, because the reason is that first we will come to a blocker of time zone difference. So that's one thing that I haven't kind of included in the model, but I think it's a sanity check. We can do that. We can keep a like input column when we are doing the feature engineering part. We can simply have a new column of if there is any time zone difference, right? So for the US case, it's obviously is going to be always like there will be no relative difference. But for say a different location, like say for India, there will be some like for US West, it will be some 11:30 hours of difference. So these things we can think about.
So do you want to cover any additional topics to add up to your answer?
Sure. Yeah. So this is about the search time, about the send time thing, right? Like when exactly we are actually like optimizing the send time thing. But can we think about some additional thing, right? Like say if the email that we are sending to the customers, if the content of it, or like the way it's presented and all, if these are like along the terms that we have. So what we can do is that we can do a parallel A/B testing for each and like each and every component in our email. Like say for example, right? Say if we have some personalized content, like say I am sending you a mail that dear Viraj, we have this particular offer from today to tomorrow 10:30 p.m., right? So if I am going to have your name right in the subject of the mail, that's going to derive more customer satisfaction, like that's going to help you. So obviously that is going to be a better way to kind of address or rather to deal with the people and all. So we can do an A/B testing here that if we include the name of the customer, the first name in our mail, and if we do not do that, what's the comparison between the two? So this is one A/B testing we can follow. Second thing is that like inside the mail, what's the location of the button that we can have? Like say the location of the URL thing that can be at the top, that can be at the center, that can be at the bottom, right? So we can do an A/B testing here also. So as to arrive at a better customer satisfaction thing. And third one is that we can like think about the content that's there in each mail, and we can also optimize it further. So not only we are doing it for a time point of view, but also we are making sure that the content is like superior to anything, right? So
Makes
that can
sense.
also help. Yeah.
Yeah, makes sense. I mean, I think the way I agree with you, the way I would look at it is we'll have set of models to build different type of email content, and then
Yeah.
on top of it, you can fit this your send time optimization model to decide when to send it to a customer.
Exactly.
Okay,
Yeah.
makes sense.
Exactly. Right. Yeah.
So briefly in terms of feedback, maybe asking the interviewer, what are your assumptions or stating them upfront? For example, availability of data. Other could be if we don't have model today, it means we have some static time when we send the emails. So does that mean the data is bit biased? That every day we just send it at 9 o'clock in the morning.
Yeah.
I don't know if that data is going to help you to take out the bias and then still build a new model out.
Yeah.
Those
So
are the questions. Yeah, go ahead.
yeah, sure. So about the second question, right? Like what, how we can kind of remove any kind of underlying bias in our system. So I think I mentioned that we are going to send this particular email at a randomized time frame. Like say for each of the 500 customer that we have, if we simply send them. So initially I told about it can be at 12 p.m. Local time. But yeah, I think I need to revise that particular thing. We can simply send it at any time so that we have some randomness in our data, and randomness is simply going to eradicate any bias.
Um, a bit of details on how will you build a heuristic model. So, like, what are the conditions? So,
Okay. Yeah.
what I'm trying to understand is, do you think it makes sense where we use simple criteria like the local times? So, instead of
Okay.
sending email at one standard US time across different countries, can we at
Yeah.
least understand what is the customer's location? And based upon
Okay.
that, you start picking a standard time, 9 a.m. in the morning or 12 p.m. in the morning, and that's a one improvement compared to your
Right.
existing one if you didn't have that. So
Exactly.
localization,
So I
and
think I
then
can take the location data thing, right? Location attribute thing. Correct.
yeah, I mean even in US we have like what 3 or 4 time zones, right? So we might
Okay.
want to even consider
Exactly.
that based upon customer
Okay.
location.
Okay.
Can
I see.
we? Yeah, so that
I
is
think
what
I
I was
think I
referring
missed.
to. Trying
Yeah.
to simplify first. So
Right.
if you don't have anything, maybe you can ask interviewer, hey, what exactly
Okay.
you have today? What is
Exactly.
your kind
Yeah.
of current behavior? If
Yeah.
you ask this clarifying question, then interviewer can give you answers. Then you can say, hey, we can do a simple approach here. There's a
Okay.
potential to do heuristic. And then your V2 is building a bigger model.
Makes
And
sense.
maybe
Yeah.
you want
The
to
data
ask
point.
this question upfront about, hey, what is your success metric? It can be open rate or it can be click through rate.
I see.
And you
Yeah.
might want to ask how much delta you expect us to deliver. So,
Okay.
say
The
open rate is currently 25%. What is
got
the
it.
success? Is it like 200 bips more? Like take it to at least 27%.
Okay.
Um,
Yeah.
that will help
Makes
you
sense.
to make
Right.
a decision when your model is successful. Thank you, Bilwa. I really enjoyed talking to you. You really helped us walk through a data science mock interview where you talk about the customers, you try to understand what business problem you're trying to solve. You also made a discussion around how to pick between a heuristic model versus a machine learning model, explain a bit of pros and cons on that front. You walked us through how will you approach the data, explain your assumptions, the granularity of data. You then further explained about what type of machine learning model you will use, how will you test out the models, and then eventually go and deploy. That was a really helpful end-to-end process. Hey everyone, if you enjoyed the mock interview with Bilwa and you would like Mentor Good to have similar content, please mention in the comments below. Thank you.